In this video, we're going to take a look at generics in C#. I know generics is one of those topics where it's probably not so much about the syntax, it's when and why, how to recognize the situation, when to actually apply the concept. And you want to use this spicy syntax in C# or this feature and you just don't get when to, how to. So let's go ahead and take a look at some of the issues that we're trying to avoid, why generics came to be, and then we're going to take a look at the syntax, and then we're going to look through some samples and really drive the idea. And just going to say it out loud here, generics are meant to allow you to use types as values, right? So as a functional programming paradigm, you have functions as values. Reflection allows you to use your code as a value. Same with the expression API, and then you just have regular values as values, right? Here, the concept is really type as a value, and we're going to see that in a second, right? But anyway, first of all, let's go ahead and see where we're coming from, what was the old way, and what is the new way. So let's go ahead and do something with an object just representing anything, right? Let's go ahead and dump it. And by the way, if you're wondering what is this application I'm using, this is called LinkPad. Okay, so any object can be anything, right? We don't know what it is. Let's go ahead and dump it. And dump is specific to LinkPad, by the way. I'm just gonna put stuff to my screen over here. We're gonna go ahead and dump 5 and hello world, right? We write it and there is really no problem. We can go ahead as far as giving it anonymous types and anonymous object, right? Easy. So what's the problem? What's the downfall? First thing, performance. Why performance? Well, until the application actually runs, we don't know what goes in here because we're using object. Object is really just that we just don't know what type is going to go into it. There is no type checking here. So we cannot prevent you from making a mistake, and we cannot perform compile time optimizations, okay? This is also visible by having this box IL instruction here, which is basically going to take your 5. It's going to go throw it into an object, put it on the heap, and then this reference type is going to reference that. Okay, so that's about how it looks. This is why you get performance degradation if you're having to do boxing. And generally the other 2 points are in the area which is slightly more important for the majority of programmers, which is readability, being able to understand your code, and maintainability. How is this a problem exactly? In the scope of this little LinkPad script, it's very easy to understand what's going on, right? I've just written it and explained. Once you have massive applications, what's going to happen is you're going to have this class amongst the sea of other classes. Anywhere where this object is called, right, you will need to know about all the possible types available to your application to understand if you're going to mess this function up or not. Like, unless it handles every single type that is available to you, the function is not safe, and to handle every single type is not reasonable, okay? So in order to understand if you're going to mess it up or not, you will have to take a look at everywhere where this function is called within your code. So it's like 10 places. You will need to see what parameter it supplies in one place, in place number 2, what parameter it supplies in place number 2, 3, 4, and you will have to check all these places to understand what's going into this function. And by the time you're going through your 5th place, you're already going to forget place number 1, and that's just the fact of it. So it becomes hard to maintain it because this function can be in all these possible states. So this is just looking from the point of view of being inside the function, and stuff is calling it externally. Now let's take the opposite view. Externally, you want to call this function. How do you know that it is going to handle the type that you're going to get? You don't know. You're going to go and have to check, right? There is no constraints, there are no type safety, there are no compile time checks to inherently prevent you from doing something like converting a string to an integer, right? Something that's just going to throw an exception at runtime. So those 2 primary things, optimization and maintainability. And under maintainability comes like being able to read, understand your code, etc. Okay, so let's go ahead and take a look at some of the syntax and how we can solve this with generics. Generics, I think, super simple syntax. You can use angle brackets to basically start specifying or giving a name to the type. So it's same as giving a name to a variable. So this variable is named v. Whatever type we supply here, type is a value. Whatever type we supply here, we give it a name. Now we can use this type anywhere within this function. We can use it as a parameter, right? So we specify that the input parameter has to be of this type. We can say that the return type has to be this type. So if we then go ahead and try to return an int, oh no, this can't be that. So here, and also you can use it inside here. However, at this point, this is not too different from an object, other than if we, for example, do idump, same as I did before, and we gotta just remove the return. Let me just get rid of this value here. So let me just print this, and the same thing is happening, right? It's same as we had an object. The important thing here is that we're not actually boxing anything. So we're kind of like taking a little step back and looking inside and outside. We understand that we can have this type t. Okay, so this is the second thing about generics. We can now that we identify that t is something and we can use it in the scope of this function, we can basically say how narrow, like how many types do we want to support. A real simple example of this would be giving it a constraint that you can scope either to structs or classes. Structs are like value types, and classes are reference types, right? So how do we specify a constraint to how much class, what types do we permit? You say where, and then you take your type identifier and you say what it inherits from. In our case, we say that it's a struct. We can specify some other special keywords, but for example, if we say it's a struct, it's a what's called a value type, so we can pass things to it like 5 and true. And then if we say that it's a class, you can see the other ones are permitted and the other ones are highlighted that they're not permitted. Okay, so this is pretty much how you can decide what you want to use in here. And generally speaking, you can let's grab this in 64, and I'm just gonna navigate to it. And how you want to decide which types you want to put in here is you would usually look at a struct like integer 16 or integer 32, which is int. This is I think it's called short. This is integer and this is long. So on integer 32, you can see it implements types iComparable, iConvertible, iFormatable, iComparable to int, iEquatable to int. So this is where you can start comparing things to specific types as well. Okay, if you specify these, but I'm not going to go too much into that. We're going to take a look at other things. Just understand, if you want to get an idea of maybe practice something, just look at some structs, look at the interfaces they implement, and try to constrain by those interfaces and see what common functionality you can extract from that. Because at this point, we're only looking at the surface of this class here. And let's actually take a look at something else. Let's say we have a class, but we also want to create a new type of that class. Well, anonymous objects, anonymous types don't have a constructor, right? Those are kind of defined at compile time and they're just there. Strings, not really. Let's go ahead and create our own class. We'll say A, and that will be just it. And if we go ahead and say new A here, this will be fine, right? And let's go ahead and make something like public static int I equals 0, and every time we create this, let's go ahead and increment this, right? Let's format this a little bit. And here I'll create it the first one. So once we dump it here, let me go ahead and output 1, and then I'm gonna go ahead and new up type t, right? So this is what new allows you to do, and let's say that we're returning the same type here, which is class and new. So if we wouldn't have new here, we would not be able to call new on this. And sometimes just because you specify type A, it doesn't mean that you're gonna have new and that you will be able to create that new type. So this can be sometimes very useful to just call new on this. And let's just go ahead and take a look at this. I'm not sure what that menu was, but I guess, no. Do we wanna, let's go ahead and dump it here, right? So 0, 1, maybe something like this, brackets, right? So 1 and 2, every time we create it kind of bumps the number up. So other things you can do with the type, specifically, you can try to use the activator. And I mean, this part was meant to be about the syntax, but I'm kind of like trying to overlap syntax with what you could potentially do with it, right? So if you don't have new, you can still create the type by using the activator, right? I think just new is a little bit more performant. I'm not exactly sure, so don't quote me on that. But anyway, here are generic functions. So you specify generic parameter. You can also specify that you can have an additional one, and this return type is really what you want, and this is what you're going to create, right? So you see there, the static type checking is helping me there. And let's say that I will provide something like an integer and an integer, and I mean, that's gonna stop me. So let's go ahead and supply a here. And by the end of it, if we new up an integer, I guess that's going to be 0 as well, right? But that's going to give us a, what's it called, the int32 type, I think, under the covers. So multiple type parameters. You can also like sort of interweave them. So let's say that our a is generic, and this is where we're going to be expecting that a is going to be of something like type R. T is going to be of type R. So unless we go ahead and give it a type of int, it's not gonna let us. So this is kind of what the kind of hoops that we'll have to jump in. Sometimes it will be nice enough to recognize the type for you, sometimes not. But any constraints like that you are putting in here in the where clause and the type parameters that you're specifying for the functions, all those rules are true here. And just generally understand that the scope for the class is everything. So if you are going to be taking this type and putting it in here, you'll see that it's kind of, this T is overriding it. So let's go ahead and just remove the T from here. You can see that you can, you don't really need to specify this bit here anymore because the T comes from the class. You can really have a generic function on a generic class. And if this would look, if this is something like static, you can then go ahead, let's say int, and then calling do, because this is static. If you just have a, calling do won't work quite as well. This is where we would have to specify both of these in order for this to work. Kind of parameter there, done. Okay, hopefully that more or less makes sense around the syntax. You give a symbol that represents some kind of type that you're going to pass in here, and then you basically enforce that something else has to be that type, but by using it there. And I mean, you can pass it to other generic functions to kind of drill the idea of type as a value. I'm going to create a little program where I'm going to simulate us feeding animals. Animal is going to be located somewhere, and they're going to eat a certain type of food. I'm going to go and feed them. Okay. So really simple. How more simpler can this be? We're going to have some kind of animal. Okay. And this can be an interface, really. I don't mind too much. An animal is going to eat a certain type of food, and it's going to be at a certain location. Okay. Let's go ahead and create our first animal. We're going to have a duck, right? And a duck will implement a animal. Okay. And we're going to need some food. So what does a duck eat? Well, a duck will have to eat something like bread, right? So maybe seeds. I don't know what's more healthy for a duck, you know. But that's something that we can definitely eat, right? So bread, and then location, where are ducks usually located? Pond, lake, something like that, right? Let's go ahead and put a pond here. Now, you can see that there is a bit of a problem here. Nothing stops us from trying to feed a pond to a duck. So we gotta, we gotta do a little bit of type enforcement, because from this idea of what types represent, we're trying to enforce a structure. And it's really about having entities and process, okay? So you're gonna have a set of entities which you've bound by your where clause, by your constraints of generic types. So you're only allowing a certain group of types into your process, okay? So something. So in our case, the process is feeding animals. The actual thing that goes into it are going to be like animal, bread, pond, and stuff like that, right? Let's go ahead and do a little bit of enforcement or constraints. Again, interface, this can be food, right? And this will inherit from food. Cool. This is now where on the animal interface, we do the enforcement of saying where f inherits from food. Okay, and if we then try to, do not close this. If we then try to put the pond where the food is meant to be, we're gonna get an error. So, I mean, even though if we close this off, okay? So we really gotta have something that let's feed our duck seeds. I think that will be a way better approach. And I mean, the same with the location. So let's go ahead and copy our location. And maybe you're kind of seeing where I'm going here. You can see I'm not really using any values to create my application. I'm not using any parameters, names. All of my values are types, right? So, but you can still kind of understand where I'm going with this, right? So this is where the location will have to be, the L will have to be a location, right? So if we go ahead and create a lake, right? If we give it a pond, semicolon there and comma there, okay, yeah. So yeah, if we're a pond, everything is fine. If we are at a lake, suddenly everything is not fine, right? So hopefully you get the picture. Let's proceed with actually, building up the application. So we have our animal that eats seeds and kind of sits at a pond. Let's go ahead and give this I'll give this a default void eat f food. So we're just gonna eat some food, and I don't think I actually need this thing here. Yeah, I can just implement it. No default, that was a Java syntax. So anyway, a default implementation on the interface where I'm really doing it for the purpose of a simple. I don't want to implement too many things. So let's go ahead and say that what kind of animal is this? So we'll say this. We'll get the type, and we'll get the name. Is eating. What are we eating? We're eating type of f. We'll get the name. Let me go ahead and close this for now. We're gonna see this is eating at. Let's say type of L. We can implement these functions on the classes, but I feel like that would ruin the example really, because notice that I'm not using anything but values. Sure, this is like a specific thing that I'm trying to do, but the rest of the stuff is really the scaffolding around it. Let's go ahead and create our new duck, and let's go ahead and yeah, let's just go an abstract class. Why not? All right, where we're just going to eat, and yeah, what are we giving it? Let's go ahead and try to give it bread. We cannot, because it has seeds as the food that it eats, right? So duck is eating seeds at a pond, right? Be a little bit more English, yeah. There's our little application. So we can take it a little bit a notch higher. We can go ahead and say we want a public class animal feeding context, where we will take an animal, we'll take the food, and we'll take the location, okay? And this is where sometimes when you're implementing this process, it can get a little bit crazy with the amount of generics that it uses, but let's go ahead and keep doing this. So where animal is going to be of type animal, where it's going to have FNL. So now you will see that this highlights because it really wants you to define these same constraints, okay, to enforce all of this. Now that we've got this, let's go ahead and C2R, we will accept an animal. We are going to save this animal. Let's go ahead and, I don't know, put it somewhere here. Animal. And let's go ahead and public void feed, where we're going to, again, accept some kind of food, which is what we can pass to this function here. Eat, just keep passing the food into here, and public void go, or let's say arrive. Oh man, let's do something sweet. I like implementing these sort of things, so let's just go ahead, put this here, return this, so all call paths returned, and now we do something like arrive at, and again, just get our type of L name. All right, so now instead, let's go ahead and, you know, create our animal feeding context. So we'll grab this. We'll go ahead and create a new one of these, where here something a little bit uncomfortable may happen, where we might need to do something like this, right? So seeds, location, pond, and go ahead and have to give it our new duck, and we then gonna go ahead and feed it some seeds, but we forgot to arrive there, right? So go ahead, run this, arrived at pond, duck is eating seeds at pond, or we are feeding the duck seeds, right? This is what kind of can happen. How can we, I mean, this looks ugly. How can we, you know, optimize this a little bit? Let's go ahead and make a public class factory. In the factory, I'm gonna well, try to keep it really simple. We're gonna say create, gonna say f and del. This is going to accept an animal, f and del, animal, just like that. This is going to be a static, and I just forgot the a. And really, I mean, this could take all these constraints as well. Go ahead, format. Don't need to format this. And we can hide something like this behind an interface like this, right? Go ahead and give it an animal right here and return. And let's just say A, F, and L. Probably worth calling this A as well. Let's say factory. Need to make this public, wherever this was. Public. Let's create a new duck. I don't think this converts too well. Let's try something along the lines of this. Sometimes you have to fidget with it. I don't know the exact constraints for how it decides when it can optimize it, when it can't optimize it. But here you can see when you're running into a problem like that, sometimes you need to fidget with it a little bit to kind of make it fit this model. But you still get the same result from it, right? So still following the same process, but also making it a little bit easier. So the point is, you kind of want to hide the generics away sometimes as well, but the mechanism internally does all the type checking, and you get that compile time check. Okay, so again, just to summarize, quick application using type as a value, right? So that's pretty much it. I know this is not very realistic. The more realistic approaches are having stuff like dependency injection containers, having your containers list, general containers, wrappers, having classes with configuration, stuff like Mediator, etc., right? There are many examples that use them, and generally, again, if you can identify a category of entities that have to go through a process, you will be able to use generics there. So let's go ahead and check out a couple examples where I will use no generics, I transfer into generics, and then we're going to use take a look at a mediator parity kind of thing. So In this example, really quickly, we have some kind of type of content. So content in terms of a post, a Facebook post or a Facebook comment. And we want to hash. So we want to hash that comment. We want to be sure that the comment that we're getting is specifically unique. So if you are distributing spam comments, if you are spamming the same comment all over the places, we won't be able to understand that it's a unique comment on that specific post without hashing the post ID, right? Otherwise, we're going to detect it as a duplicate. So what we have here is we have a hasher that specifically depends on concrete types, right? So there is no generics here. Well, not really concrete types, but we take in the content and then we check what type of content it is, and then we have to return a specific hash, okay? So here you can understand or kind of like recognize a place where you need to use generics. We have a content, we have post and comment both inheriting from content. Then content hashing strategy hashes with text and author, and then a comment hashing strategy just hashes with author and post ID. So we spin up a specific hashing strategy per piece of content. So what happens when we add an extra piece of content? We have to also go and edit a second place. And this is coming back to maintainability question, right? You edit code in one place, right? You create an extra content piece, and then you have to go edit it somewhere else. That's not good. And you'll probably have to create another hashing strategy or reuse some like the regular content hashing strategy that already exists, right? So hopefully that kind of gives you an idea. If you have to edit code in two places when you're making one change, that's already kind of a red flag to maybe think about like sharing the process. So let's go ahead and see how this gets solved with generics. So kind of the same usability. We're still passing stuff in here, but now we have a iHashing strategy interface, right, where we say that the content, in between the content and the actual implementation, we define another class that basically says, right, I'm still content, but for me, you will have to specify the hashing strategy, right? So now when we define the post and the comment, we already know how we're going to hash it. So if you're going to take a look at the post, you already know that there's going to be some kind of hashing going on with it. We know how we're going to hash it, right? And then on here, you will see that here we're getting a little bit of like, we don't actually know what type we're getting. So we're just getting content passed right here. And that's okay. We will need to do a little bit of type conversion. But in the end, once it comes to the hasher, we're just using the activator to create the type of hasher that's specified. So now if we write one more piece of content, we don't need to remember to edit this class, right? Because with this solution, you're going to be right. We need one more thing. Yeah, okay. I'll put this thing. We parse some JSON. We can now put it into this model, and we can process it somewhere else. Oh yeah, that's good. Yeah, ship the code. You ship it, and then you get exception that it's not getting hashed, or you will slowly realize that, hey man, things are not getting registered. Why? Because we hash them to the same thing, or we don't hash them and they are considered duplicates. So the unsexy thing about this solution, I guess you can say, is this bit right here where we kind of can't recognize it, right? But this is where you kind of just like start throwing a little bit more generics, where in between the iHashing strategy and the hashing strategy, you put another interface with the type, right? And you say that the type is of some piece of content, and this interface, you go ahead and you point it to this abstract class implementation, right? And it's protected. So you still do the casting, although now when you, where is it? When you do your implementation, you say what kind of content you can hash with this hashing strategy. And here you don't need to do the casting anyway. The hasher still looks the same, and the usability still looks the same as well. Okay, so this is pretty much the concept. You want to balance your capability, user experience, or developer experience, and still maintainability. So those are the really three things. What can you do? How easy is it to do that? and how easy is it to maintain it. So those are the three things that you're going to be balancing. Because once you're looking at this and you have generics flying left and right, this is the sort of logic that you don't want to be writing too much. You don't want to be going in there and you want to specify one generic on your class. Once you're writing something and it's going to be looking maybe closer to something like this, if you have to write this all the time, it's not good experience for the developer, right? And as we're looking at this example, let's go ahead and dissect this a little bit. Okay, so this is the Mediator parity. If you've heard about Mediator, this is a rough implementation of it. We have a request handler. Requests go in, we give it some sort of a request. It's going to invoke a specific handler for it, and I mean, that's pretty much it. So we have a request where we specify the response type in here. I create two requests, get age and get name. One returns an integer, the other one returns a string. We then create a handler where the handler is an abstract class of the iHandler. This is, I do this just to be able to store this a little bit neater in my dictionary here. We have an iRequest of type T, so this is going to return T and take an iRequest of type T. And then when I implement the actual handler, I have a T request, which takes in one of the requests and returns a T response. So T request is an iRequest that returns a T response, right? So it will be returning a string. So this is how we enforce the type, where the handle, where the thing that goes into it is an iRequest of type string. And if I get age is a iRequest of type int, it will return an integer, right? So throughout, we're able to enforce the return type. So same as here. So in this abstract class, really, we do the same trick that I've did here to kind of create an abstract class that will implement the interface and kind of pass it here. Same thing happens here, right? So abstract class, default implementation of the handler is right over here. So I override it. And then for the next class, for the actual implementation, I go ahead and tell them to give me a solution that's going to be protected, right? Otherwise, I do a little bit of casting. So all the source is going to be in the description. So if you want to dig into this a little bit, and then after this, go ahead and take a look at the actual Mediator implementation. So to get an idea of how it works, okay? Abstract class for the handler. Let's go ahead and implement it. So the actual developer experience is here. We specify handler, what goes in, what comes out, something comes in, and then we return a value. Again, handler, what comes in, what comes out. We specify what goes in, what comes out, right? Really easy. So this is what you kind of want to be writing. And then request handler. So on my reflection stuff, I already showed you how to kind of scan your assembly for specific types. That's what Mediator does internally as well. I've decided to not put that logic in here and kind of just bake in the stuff that I've declared here in this dictionary, right? So type of the type of the handler maps to the handler instance. I go ahead and I go ahead and grab my type. So I grab the handler, if handler of type handler T. So I cast it to this type which accepts this request type, and then I go ahead and invoke it. Otherwise, a default return default. You can throw really, but yeah, I return default, right? And this is how you basically get your static typing and kind of enforcing a process. And if you have juniors joining your team, again, this is just another example where they have to write this, and now they have a structured way. So if you want to write new logic, you already have specific process that you have to follow to write your code. You understand your business, you understand what's the repetition for each individual thing you do. It's a process which you can follow. So things like products change, some entities change, but they can all follow this process. So Mediator is really generic, so it can really fit any business model, because it's request and output. Same thing here. So just a really nice, neat, Mediator is just a really nice, neat way to structure code. But hopefully you get generics a little bit more now if you didn't know anything about them. Just remember, in summary, entities, process, narrow your entities, make sure they fit your process, and really it is the user experience. So you want to be writing these things and these things. The structure of how your whole thing looks, in my case here, the handler infrastructure, the request handler, you write that once. Okay, that's your framework in which you put your actual entities that are going to go for the process. So the process doesn't change too much. It's the things that you are going to be developing with. So these are your objects. So your functionality and your requests. In our case here, again, it's the functionality of being able to hash your content. Okay, the actual process of applying that process to that entity is, automated, and you no longer have to go ahead and maintain in the node generic way some other table somewhere else. And really, if you have something like this, chances are it can be used in 3 different places. So you have to make one change and update 2 other places for that change to be working properly. Okay. Anyway, this will be the end of it. Thank you very much for watching. If you enjoyed it, leave a like, subscribe. Any more questions, leave them in the comments or come ask them on my Discord server. I also stream on Wednesdays and Sundays. Come join my Twitch, link in the description. Have a good day. And hopefully, I'll see you in my other videos.